Hey everybody, welcome back to my channel. In today's video, we're going to build off of my most previous video where we discussed how to multiply polynomials. And to be perfectly honest with everybody, this lesson is not exactly a requirement that you have to know. This is just kind of a shortcut. The whole point of this lesson is that there are some special situations where if you notice that it is a special situation in a multiplying of a polynomial, you can kind of do a shortcut so you don't have to actually work out all the steps of FOIL. You don't have to actually distribute all the parts in the distributive property. You don't have to do the entire problem vertically or draw the table, all four methods that I showed in my most recent video. The hard part is recognizing that you have a special situation. But like I said, this is completely optional. If you don't ever even recognize that you have one of these special situations and you just go about doing your business the normal way, you'll still end up with the right answer. But the more you do these and the more you get comfortable with them, the more you will realize, apologize for that, that you have certain cases that are quote-unquote special situations. For example, if this was question number 1 right here, most of my students, the first day they learn this, would not even know this is a special situation. And so let's just say, for example, they were going to use the distributive property to solve this. They would do x times x, and they would get x squared. They would do x times 4. Now this has a minus in front of it for the subtracting, so it's really x times like negative 4. And then when they go to distribute the second half of the question, this is positive 4 times x. And then you have positive 4 times negative 4 right there, which when the signs are different gives you a negative. And so usually what I do with my kids, the first time we introduce this in class, is I just have them work it out like normal. And I say, okay, what do you notice it was kind of unique? What was kind of strange about your final answer to this question? And almost every single kid can recognize, oh, wait a second. These two terms in the middle, right? Sometimes they're called the OI, the O and the I if you did FOIL, right? These two terms in the middle are going to cancel each other out. Negative 4x plus 4x, right? That equals 0. And so instead of having a trinomial, 3 terms for your answer, you only have a binomial for your answer. And that's what makes this a special situation, right? What's special about it is these two terms in the middle will always cancel each other out. And so if you can recognize that at the beginning of the question, you don't have to go through all the distributing. You can kind of take a shortcut and get the answer in about 5 seconds instead of 45 seconds. Okay, so that's what the shortcut looks like whenever you work it out. How can you tell that you have a special situation before the problem even starts? Okay. Look back at my number 1 question here. What do you notice about the two parentheses? They're almost identical, right? They have the same terms, x and 4. The only difference is one has a plus sign and one has a minus sign. That is your special situation. Okay? The terms are the same. The only difference is one is a plus and one is a minus. The parentheses are almost identical. The only difference is one is a plus and one is a minus. So here it is again on number 2. We have an x and an x. We have a 6 and a 6. The only difference is one is a minus and one is a plus. You can see I have flipped the plus sign and the minus sign from number 1 to number 2. Up here the plus sign was first. Up here the minus sign is first, but it doesn't matter. It's the same scenario, right? One is a plus sign, one is a minus sign. Here, one is a plus sign, one is a minus sign, just in the opposite order. So if you recognize, oh, this is a special situation, it's going to be just like number 1. It doesn't take very long for kids to recognize, oh, all I have to do is the first times the first, x times x, and all I have to do is negative 6 times positive 6, excuse me. And I don't need to do those two terms in the middle because they're just going to cancel out like the last one, right? On these parentheses, it would have been positive 6x and negative 6x. Right? So here is kind of your general format. You'll see this in almost every single algebra book ever in the history of time. They call the first term the letter A. They call the second term the letter B. That's just how they do it. It's kind of abstract, and a lot of times when my 13 and 14-year-old kids see this in 8th grade, abstract thinking isn't always the easiest for them. And so this is what it looks like in an algebra book. In college algebra, I think this may even show up, and they'll also have a plus b and a minus b. And you'll always see this. You'll always see a squared minus b squared. And that's just kind of your reminder that if you want to do this the fast way, you just do those two, square them. You do these two, b times b, or b squared, and then it always, always, always has a minus sign or a subtracting sign in between your two terms there. And that's simply because your two signs are different. And when you're multiplying two things that have different signs, it has to be negative. You will never, 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 never get one of these that has a plus sign in there. There'll always be a minus sign in there. Unless they're really weird and they write it backwards. Like they could technically write it backwards like this. I don't know, I'm kind of off my screen. They could write it backwards like that and have negative 6 plus a and positive 6 plus a. And in this case, it would be backwards. It would be negative 36 plus a squared instead of a squared instead of a squared minus 36. This rarely happens. Only whenever they're being very, very rude will they do that to you. But as long as the variable comes first, right, the x comes first in the parentheses, it'll always look like this. Okay, let's look at a couple more examples so we can fly through these. My kids actually really enjoys these just because they can go so quickly on them. Here's board number 2. Special products of polynomials. Kind of got wiped off there at the top. I apologize for that. All right, here we go. Number 1. I'll give you a second. You might know the answer in your head, right? Most kids can think of this in your head. If you want to write it out, go ahead and pause the video, work it out real fast. Shouldn't take you more than 20 seconds. Okay, you can see the y's are in both parentheses. We have one with a 5, one with a negative 5, so the signs are different. Everything else is exactly the same, so I know all I have to do is y times y, and then positive 5 times negative 5. Done, right? That's a 10-second question or less. Same thing on number 2. Now, I put a coefficient in front of the w here instead of just a regular y or regular x. Now we have 2 w's. That's all right. Do it the same way, right? It's the same scenario. The first term in each parentheses is the same. The second term is the same. The only difference is one is a plus and one is a minus. It's the same idea, right? 2w times 2w, that's 4w squared. And then positive 4 times negative 4, negative 16. Boom, perfect. Grand finale on this board. You've got the same situation, right? 4y and 4y, 3 and 3. They're perfectly identical. The only difference is one is a minus and one is a plus. So this is another case where my special situation applies. I can do 4y times 4y, which is 16y to the second, or 16y squared. I can do negative 3 times positive 3, which is negative 9, and awesome. I got that answer in 10 seconds or less, right? These questions are so good. Once you get the hang of it, and once you know, oh, this is a special situation, I can kind of do the shortcut. Okay. Now, we're going to switch. There's one more special situation to discuss. And this one is a little tricky. Switch my board out here. Here's another special situation. Now here's exactly what most of my kids do. I have 8th graders who do this every time I teach this. They'll see, oh, okay, this kind of looks like the last one, right? The only difference is now they are exactly the same, right? This is a plus and this is a plus. It's not like the last board where we had one was a minus and one was a plus, right? The signs were different. On these, the signs are exactly the same, plus and plus, plus and plus, minus and minus. Don't do this, because here's what some of my kids did this year. They did the exact same thing that we just did on the last board, and they would say, okay, well, isn't this your answer? X squared plus 9? Oh, that was easy. Oh, I'm sorry. You can't do the same shortcut on this one because this is not the same type of a question. So this answer is not correct. Now, it's close. This is part of the answer, and plus 9 is part of the answer, but you're just forgetting something. You're forgetting something in the middle. These answers will not be binomials. These answers will be trinomials again. You'll have 3 terms in your final answer. All right, for example, let's imagine that we didn't even know that this was a special situation, and let's just work it out like we normally would have, right? If we were doing FOIL or the distributive property, we would do x times x, and we know that's x squared. We would do x times 3. Okay, I know that's 3x. And then just for emphasis here, I'll switch colors. And to do the other distributing, we would take the 3 times x, and that's 3x. And then we would do 3 times 3, and we would get 9. Right? And so for my kids who actually work it out, or if you didn't even know any better, you would do this, and you'd be like, oh, that's kind of neat. Did you see what's kind of special about this one? Right? You see how these 2 terms in the middle, they are identical. Right? Instead of being complete opposites like we had on the previous boards, now they're exactly the same. And so that means we can just add them together. 3x and 3x make 6x's, right? And here is your final answer. I don't know why I'm writing it underneath. I've been writing it off to the side on every single other question, so I should probably keep that going, right? So that is the difference between these questions and the last questions, right? When the signs were different in the parentheses, and I go back to this board, when the signs were different, you don't have a middle term. You only have a binomial, two terms, two things being added or subtracted. When the signs are the same, these are identical twins, plus and plus, minus and minus, plus and plus, and everything else is perfectly matching, right? You're going to have this third term right here. You're going to have a trinomial again. And what makes this one special is the two terms in the middle are going to be exactly the same, 3 and 3. And it'll be like that on all of these, right? And so what is the shortcut? How can I do this quicker so I don't have to work all this out? Now, that wasn't horribly hard, but could I do it even faster once I got the hang of it? I hope you can. Here's the shortcut. Okay, it's very similar to the last one. If you recognize, okay, this is a special situation, how can you do it quicker? It's very similar to the previous shortcut. You can still do x times x and get x squared. You can still do 6 times 6 like we did on the last ones and get 36, but ooh, look how I did that. I left a little space in the middle, right? There's always going to be something in the middle. You can't forget this middle term. What is the middle term? In order to get the middle term, here's what you do. You do this times this, and then you square it, right? You do 6 times x, and then you, hang on, I said that wrong. Let me back up. You do 6 times x, and then you double it, right? You take it times 2. Because your two terms in the middle on this one would be 6x and 6x. So let me do that one more time, right? In order to get the middle term, you do x times 6, and then you double it, right? 6 times x is 6x, and if I double that, 6 and 6 would make 12 in the middle. Okay, let me try another one since I had a little trip up on that last one. On this one down here, we would do y times y. That would be y squared. I could do negative 2 times negative 2 and get positive 4. Now look, I'm leaving that space again. What goes in the middle? You take this times this, and then you double it, right? You take y times negative 2, which is negative 2y, and then you double it. Negative 2y, if I doubled that, and I gave myself another negative 2y, that would make negative 4y's, right? And so that's what makes this one a little bit harder because you have to do a little mental math. You have to do that. Those two terms multiplied together, and then you have to double it, or you have to multiply it by 2. Okay, let's do one more. Here is the fancy way you'll see it written in a book, right? Sometimes they won't even write 2 parentheses. Sometimes they'll just put 1 parentheses and square it. It's the same thing, right? And so you'll always do this number squared. That's what a squared means. So like on this example, we would do y times y. So that would be y squared on my example. And then what I like to do, just because it's easier, I like to do the end. You'll do b times b, or in my case, 5 times 5, which is 25. And then here's the hard part. How do you get this in the middle? You do 2 times a times b. So I'm going to do 2 times y times 5, right? 2 times y times 5 is, well, let's see, 2 times 5 is 10. So that's going to be 10 y's, right? So that is the way that you'll see it written in like every single algebra book you'll ever look at in your life. What I do sometimes is I just take this times this and I double it in my head. 5 times y and then double it. 5y and 5y would make 10y. They don't have to write it in parentheses with a square. They could write it like this. Same idea though. You would do x times x. I like to do the end. 4 times 4. And then how do I get that piece in the middle? I take this times this and then I double it. X times 4 and then I double it. X times 4 would be 4x and then I double it, and doubling it just means the same thing as multiplying by 2. 4 and 4 would make 8x's, right? So that is your other special situation. When the parentheses are identical twins, exactly the same, or when they have the little squared on it. That means it's the exact same thing, right? Okay, we're almost finished. I'm going to wrap this up pretty quickly. I want to try to make my videos a little bit shorter. 20 minutes is a little bit too long. Most of my previous videos have been getting closer to 20 minutes. Okay, the hardest part for some of my kids is they want to do a shortcut on every single question. And I'm like, ooh, you can't do it every single time. Sometimes you have to do FOIL all the way. Sometimes you have to distribute everything out. Sometimes you have to do that vertical format or draw that table that I showed you in my previous video. What situations here are your special situations, right? What am I looking for? I'm looking for parentheses that are identical twins, exactly the same. Exactly the same. I think those are the only ones, right? These two are special situations, the ones I just showed you. Parentheses are exactly the same. Or I'm looking for parentheses that are almost identical. The only difference is one is a plus and one is a minus. For example, this one, right? See how one is 3x minus 1 and the other one is 3x plus 1? Which other ones here on my screen are like that? You can pause the video if you really need to. Let me look. Not this one. See how this has x and this one has 2x? That's not a special situation. There's no shortcut on that one. Is it this one? Actually, I think it is, right? 6 and 6, x and x, one's a plus and one's a minus. This is a special situation. Is this it? I have a plus and I have a minus. Oh, no, it's not, because I have two different numbers. It would have to be 5 and 5 or 2 and 2. If those numbers were the same, then it would work. This one isn't going to work either, right? My signs are different. One's a plus and one's a minus, but one is a 4 and one is a 3. That's not going to work. This one, although I think this is good, right? 2x plus 4 and 2x minus 4. Yeah. Right? And so my purple ones would be the ones that would only have two terms for the answer, right? My purple ones would all have just two terms. That says 9x minus 1, if I can squeeze that on camera there. This would be 36 minus x squared. And my red ones here are the ones that are going to have three terms, right? Where you do the first term squared, the second term squared, and then you do this times this and double it. And then the first term squared, the last term squared. You see how these always end in a plus, and the other ones always end in a minus? And then I would have to do that middle term. 3x times negative 4, that would be negative 12x. And then I have to double that. Negative 12, if I doubled it, would give me negative 24x's. My marker is running out of room there. Here we go. Negative 24x plus 16. Okay, so there you have it, guys. Those are the quote-unquote special situations for multiplying polynomials. Like I said, you don't actually have to do these shortcuts. If you love doing FOIL, if you love doing the distributive property, if you love doing the vertical format or drawing that table that I showed in my previous video, you can do that on every single question. You'll get every single question right, and it might just take you a little bit longer, but there's nothing wrong with that. As long as you get the answer, I don't care how long it takes you to get it. One more chance to give you guys some practice on this. Students in my classes in Marshall, I'll post a video, or not a video, I'll post this video and then I'll post an assignment or a group of questions on our class website that you can work on. If you don't go to Marshall and you don't have a Big Ideas Math account, you can go to this website, kudasoftware.com/free.html. They have a whole list of assignments you can do. It also includes an answer key so you can check your answers. I think the one you want to search for, it's on the right-hand side underneath polynomials. It's called like multiplying special cases. I think it's called multiplying special cases. That will give you some more chances to practice this on your own instead of just watching me do it. So once again, thanks for watching this video. I got a little bit closer to under 20 minutes. But if you made it this far, I appreciate the support. And feel free to email me or respond or make a comment if you have any questions or if you have any other topics you would like for me to address in future videos. Thank you so much and have a good day.